Hey class, welcome to the next video on inverse derivative trigonometric functions. In this lesson, we are going to be taking the derivatives of inverse trig functions, in particular, the arctangent, the arccotangent, the arcsecant, and the arccosecant. I just want to clarify, arctangent can be rewritten as tangent inverse, and that goes same for arccotangent, arcsecant, and arccosecant. These are just functions, and in class I'll go over why we need to restrict the domain for each of these trigonometric functions. And if you saw the last video, you'll know that sine and cosine are not monotonic. They're not strictly increasing or decreasing, so the inverse function does not exist. Let me write that out. Let me draw that. So sine and cosine are periodic, just like the other trig functions. So the inverse does not exist unless we truncate the domain and we redefine it so that it is a function. So enough of me babbling. Let me just go ahead and just show you the derivative rules for these four trigonometric functions. So the arctangent is 1 over 1 plus u squared times u prime. The arccotangent, again, if you saw my last video, arccotangent, you'd expect that this be a negative. And since cotangent and tangent are reciprocals of each other, the derivatives of the inverses are just their negative counterparts. The arcsecant, the derivative arcsecant is 1 over absolute value of u times u squared minus 1. These last two, arcsecant and arccosecant, their derivatives are different. They both need to contain an absolute value here. And if you see the graph of secant, then you would understand why that would need to be absolute value. Now I'll show that in class. For time's sake, I just want to show you the derivatives and do a few examples. Arccosecant, again, arccosecant, so negative absolute value of u squared minus 1 times u prime. Let's go ahead and use these new four derivatives for the following examples below. Okay, find the derivatives for the following functions. So here I need to identify what is my u and what is my u prime. So if I use a derivative rule for tangent, the derivative rule for tangent is 1 plus u squared times u prime. So using the rule, all I would have to write is 1 over 1 plus u squared times u prime. And the final form would be 1 plus 9x squared. I'm sorry, I'm getting a little ahead of myself. That is the derivative for arctangent 3x. Now for part B, the arcsecant e to the 2x, that would have to use this rule right here. So the derivative arcsecant e to the 2x, first state your u. My u is e to the 2x, my u prime is e to the 2x, and then chain rule times the derivative of 2x is 2, so my u prime is 2e to the 2x. Now let's go ahead and take the derivative, use the derivative rule for arcsecant. So it's going to be this one here that I boxed, 1 over the absolute value of e to the 2x. And then e to the 2x squared minus 1 times the u prime, which is this, 2e to the 2x. Let me rewrite this. 2e to the 2x, if I multiply the 2e to the 2x times 1, it's just 2e to the 2x. Now, the absolute value of e to the 2x, well, e to the 2x is never negative to begin with, so I don't need to write the absolute value. I could leave it like that, but there isn't any x that makes e negative. There isn't any x that makes e to the 2x negative. So I'm going to go ahead and rewrite it without the absolute value. Times the square root of e to the 2x squared. Well, going back to pre-cal, let me refresh your properties of exponents rules. A number raised to a power that's also being raised to a power, well, all we have to do is multiply the powers. So if I look at 2x and then raised to the second, well, we're just going to multiply 2x times 2, which is 4x. Okay, so let's finish off the problem. E to the 4x minus 1. And then you can see that there's that you can divide out e to the 2x and e to the 2x. So your final answer would be 2 square root of e to the 4x minus 1.